Welcome, this is Attemen reporting live from the Super Day event in Amsterdam. And we're here with Thomas Schultes, who is Director of CSCS and who just gave the keynote presentation on exascale developments and the requirements for that. So welcome, Thomas.
Yeah. Yes, thank you for having me here. It's a great pleasure. So I'm, to introduce myself, I'm a professor for computational physics at ETH Zurich, and I lead the Swiss National Supercomputing Center and the Swiss High Performance Computing Initiative. That's very much concerned with, up to now, building applications that perform at sustained petaflop performance. Mm-hmm. And now we are thinking about the future, the so-called exascale.
Yeah. Yeah, and the exascale, I mean, the European Commission and the European Union and the member states, and there's an initiative called EuroHPC, of which also Switzerland is a member. So it's really been taken seriously now in Europe, you could say?
Yes, so I would actually argue we've been taking supercomputing seriously in Europe for many years, and we have some of the most performance systems on the planet in Europe, if you count Switzerland to be part of Europe, of course.
Yeah, I do.
Depends.
Yeah. In this case, we do. Yeah.
Okay, so we have taken it seriously. There is a big push all around the world to, making the next steps. And these next steps will be challenging because we are no longer in a time where performance increases come guaranteed. Moore's law is tapering out, and so we have to deal with this reality. But it also makes it interesting. And so we have initiatives in the US, we have initiatives in Japan and in China, and now also in Europe. And I think the good thing about Europe is that, we have a combination of top-down, where the Commission manages, but also bottom-up initiatives. And we are rather strong in the bottom-up initiatives in Europe that are sometimes science-driven. So I feel pretty good with our position.
Okay. So one of the goals is to go now to exascale. Yeah. But what does that mean, exascale?
Exactly, that's a good question. In the past, we would go to petascale, which meant petaflops.
Yeah.
Okay. Or terascale, meaning teraflops. And in the last maybe 5 years, we've seen now a disconnect between the application requirements and the requirements of flops, of peak flops.
Yeah.
And so this makes it a bit more difficult to define the goal. And I think we should, so this is one view. There are, of course, people who have different views, but the view that I advocate and some of my colleagues is that we go after a scientific problem that is very ambitious, that's like beyond the horizon for any individual group, but a problem that represents a big value for society, and then we build systems to solve those problems. And the one I talked about is this high-resolution weather and climate simulations. Yeah. So there the idea is you push the current simulations that are around, have a lateral resolution around 10 kilometers, push it to 1 kilometer. And that is going to take about a factor 1,000 more performance, and which is this is highly not trivial to reach, but the payback is going to be tremendous because the models will resolve the convective clouds, which is like thunderstorms and so on. And so the models, by making them computationally more difficult, you make them physically simpler, and then they become more predictive. And so this could really push the limits on what we can do in terms of prediction of weather and climate, going from maybe days to weeks today to improve the skill of a prediction for the next season. And that could have a big impact. It also allows the scientists to understand better the development of extremes and mitigate, society to mitigate these extremes.
Yep. And of course, in Europe we are pretty good at predicting weather already.
Yes.
I mean,
so it is a very good subject for Europe because Europe is in the leading position for this. The European Centre for Mid-Range Weather Forecasting is recognized as the world leader in this field. You know, the Americans will use their forecasts when it comes to, you know, preparing for reacting or preparing for hurricanes. And so you take a problem where we are in the lead, so we can also define the baseline of today. And it's always easier to solve a problem first when you're already in a leading position.
Yeah.
But on the other side, I do think, you know, this is not just a European problem. The weather and climate and the development of extremes, whether they are human-made or not, you know, those are things that need to be figured out or determined. This is not a European problem, it's a global problem. And my hope is that with a combination of our know-how in Europe on the model and the software side, with collaboration with both US, European, and even Japanese, Chinese, you know, system developers, that we actually manage to reach this scientific goal by early mid next decade.
Yeah. So this is one scientific goal. Should there be more, or is it just sufficient to have one because this one is already representative enough?
Well, I think there are other problems that are, you know, that have a similar combination of a scientific challenge that's really difficult but still doable. You know, it's not like beyond what we can ever reach. So there are other problems that have this combination of challenge that could be reached, require an extraordinary effort, but have a value to society that merits this extraordinary effort. So things I can think of is I'm sure you could formulate similar problems in molecular biophysics, peptide simulations. So I didn't address that during my talk, but you could imagine that on, you know, drug design, materials design, that there are problems that look similar. But what I'm convinced of, and there probably some of my colleagues will disagree, but I'm convinced of that we need to have a problem that we solve. And we may need different architectures for different problems. Mm-hmm. So we should not go and pick 25 problems and say, now I'm going to build a machine that solves all of them. I think that's not going to work in the future.
But that's different from what we did until today, more or less, because then we said, well, let's build a generous purpose supercomputer because it's expensive, and then we can solve a lot of problems with that. So that's different, you say.
Yes, and we can see it with the example I mentioned, the Meteo Suisse and Cosmo example I mentioned in the presentation today, is if we take today's code, model, which is well implemented, and I try to solve a problem on a general purpose machine, like the machines they have at the German Weather Service or at ECMWF, then the machine ends up being about the factor 10 bigger than if I refactor the software, design a very special computer for this particular problem, and which is still taking off-the-shelf processors, but different ones, like graphic processors. Mm-hmm. And then I build a machine to solve this problem, rather than taking one that's in the roadmap of the vendor. And we could show that the difference in efficiency is then a factor 10. So this really means the investment I'm putting into the software is already amortized by the fact that I buy a smaller machine.
Yeah.
Okay? So the computer vendors may not be perfectly happy, but the customer is, because the overall production is lower.
But
also the power.
Probably they will then say, well, you need to buy 10 different machines for 10 different applications, and they will sell anyway.
Or others. No, this is the part of innovation. That's always good.
Okay. But today, and also I think Juncker said, well, Europe needs to be on the top 3. You are already,
well, that's what I said. It depends on how you define Europe.
Yeah, but also with European technology. So not only, Is that something which is of importance to be in the top 3 first, and second, is it important to have European technology?
I think the latter is important. I think it makes sense for Europe to want to be in the technology game, and it should. Okay. The question is, what does it mean? Which top 3 are you taking?
Yeah.
If you're taking top 3 in top 500, then I think it makes no sense. Okay. If you're talking about you want to be not top 3, you want to be top in terms of solving this weather problem. Then I would be more ambitious than Juncker. I would say we just want to be the best, period. Okay. I think where there is currently maybe a little bit a disagreement is how do you get to European technology? Okay. Do you start from scratch, or do you start with collaborations and slowly adopt more and more European technology? And I would favor this latter approach. The approach that in EuroHPC some promotes, and they are not all in agreement, but for example they do in France, is they want to go all European or all non-American technology, so they are not limited by ITAR rules and so on. And I think it's a bit a riskier approach that in the end may take longer. So I would argue if you take this more continuous approach where you adopt more and more European technology, you will end up building European systems faster. Because there's one thing we should not forget, you have to build a market, a business case around the system. So it's not just enough to invest a few billion to create a one-off system. You actually want a business case. That's what makes Americans so strong, because everything they do is not driven by government programs. It's driven by an economic case. The government programs may pick some of the cherries to accomplish certain goals, but the fact that US leads, Silicon Valley leads, is not because of the US government. It's because there is an economic case for what they are doing. And then it becomes self-funded and self-sustained.
Okay, so that's the, you could say, but that are the discussions that are now taking place at the governance level at EuroHPC and things like that. Are they, I mean, you're part of those discussions, aren't you?
Well, our government is, so we are. In that sense, we are part of these discussions.
So how are things going there? Do you have...
I think, they are progressing, and I commend that, they are really making an effort to create a European initiative to also motivate other governments to invest. So, there are some like the German government, German BMBF, Bundesministerium für Bildung und Forschung, they have already invested a lot. So they have a very healthy program. And I would argue Switzerland, given the size, has also invested a lot and also accomplished quite something. So we have a few places in Europe that have very substantial programs. And I think this EuroHPC initiative is trying to motivate others to do the same. So I think that's a good thing. Now, of course, you have to find consensus with a lot of members, which I think is not a bad idea. We're used to this consensus finding in Switzerland, even at a much smaller scale. And this is generally healthy and good to do. It may slow you down a little bit. And that's why I think we need both. We need top-down initiatives like EuroHPC, and we need bottom-up science-driven initiatives.
Yeah.
And I think with both we will keep Europe healthy.
So you talked about the importance of having an application which is important for, let's say, the whole world, like climate research, and having that as a kind of far-reaching but not unreachable goal. So that's nice and that's good defined, but how do we get, let's say, rid of the top 500 and the HPCI benchmarks, which are now kind of dominating the discussions?
Okay. Well, precisely. So the you can call it the carrot or the scientific challenge. You have to think about what you need to do to reach to that carrot. It's not just about building a computer. You know, one of the most significant investments we have to make is we have to change the way we develop software, how we implement the models. And this is where in many areas of scientific computing we are out of date. We still live in the 1980s, maybe have arrived in the 1990s. Yeah. And there are other areas like machine learning, data science that are in 2017, so they are way ahead, okay? And so what I'm arguing, and we've done actually demonstrated that it's possible to do this with this work we did with Cosmo and with Meteo Suisse, is we can use modern approaches to building a software framework that gives us more flexibility with the hardware. But now the ideas how we build the software framework will fix a huge problem, this productivity gap that we have today. Mm-hmm. And once that productivity gap is closed, people will suddenly realize that this approach that we have today, where we build a machine for top 500 and then we shoehorn an application onto that machine, like is happening now with these systems in China and the Gordon Bell prizes that they receive, for that, but with performance that is embarrassingly low, they will realize that this is not the reasonable way to do computing. So if you have an alternative, and I think weather and climate, these questions of molecular dynamics, material science, all those problems, they have large enough base that if there is a very substantial alternative to the current approach that we have around top 500, people will just go there. And then hopefully they will ignore what we believe is not the right path.
Okay.
I'm quite hopeful, but we can revisit this in 5 or 10 years.
Yeah, that would be interesting. Yeah. Just one last topic. How do you see the relation with industry in Europe between the
Okay, so in this case, I know there's a lot of discussion around industry. I think there are different models in how this relationship has to be implemented. We follow in Switzerland and ETH in particular a relatively liberal model, liberal in the economic sense, in that there are clear roles for institutions like ETH or ETH Zurich to invest in education and innovation. And so the federal government invests in innovation and education. And then we have a clear transfer step, between the innovative work, creating maybe spin-offs or startups that then get spin-off, or just educating people that then go into the commercial world and become productive there. And so in our view, a computer center like ours should work in partnership with industry to help create infrastructure like this on the industrial side. And this is where we differ a little bit from some of the European approaches. I'm saying not everywhere. In Europe, there are many countries that have a very similar model to Switzerland. Like I think the Netherlands is very similar. But it differs where some countries think that you should use the publicly funded infrastructure to help industry more directly. And so we do things a bit differently. For us, really, it's about knowledge transfer into industry and creating successful projects in partnership initially, but then you want things to happen on a commercial level without subsidies. Because if something is successful commercially, you have to scale it, make it 10 or 100 times bigger than we could ever do it at our center.
Yeah, and that's a different ball game altogether.
Yeah, and today we have the implementations, all these hyperscale cloud. We have more of them in the US or by US companies in Europe, but I think that's the model. There is the academic world that we live in and operate in, and that's more or less capped. You know, even the Swiss science budget is not going to go up a factor 10 in the next 5 years. Okay, but if there are good ideas that can be commercialized, then you want to scale them a factor 10. But if they are commercial, they also have the capital to do it.
Then you go to a bank, you get loans, etc.
Exactly.
Okay.
And as I said, these hyperscale clouds, the infrastructure exists. You know, so that's, I think it's quite good.
Thank you very much for this interview.
Yeah, thank you for the questions. It was interesting discussion.
For Prima Magazine, this was Attendant reporting.